Hi, my name's Stuart, and I'm the Magenic Cloud Practice Lead, and today we're going to talk about some cloud fallacies from the point of view of our team at Magenic that does this sort of thing every day. So the idea for this talk came from an article by James Gosling, who had found a research paper from Peter Deutsch at Sun, and he had listed the first 7, and James Gosling amended and added some more, and you can read all about it in the link below. But we're going to talk through each of the original 8, and then Magenic has 8 more that we're going to tell you about. Let's get into it. The network is reliable. Nope. I wish that were true. Anyone who spent any time in any kind of distributed computing environment, whether it's the cloud or whether or not you have 2 data centers connected by a WAN or a VPN, you're going to find that you're going to have outages and glitches and throttling and capacity issues. And the upshot of this, from the point of view of your applications, is that the network is not reliable. So that means if your teams are writing programs or moving programs to a cloud or other distributed environment, that you have to make some architecture and design changes. Now, there are lots of great alternatives to this. Fabric computing is one. The circuit breaking pattern is one. You're going to want to, if you can, and for example, you're using .NET Identity Framework, use a library like Poly that has things like retry policy, timeouts, escalation, and so on. And in the worst case scenario, you have to deal with the fact that your code shouldn't just die, but should sort of attempt to stop doing what it's doing and wait for it to reconnect again. Now, the caveat to that is if you have a container system or some other system that manages the lifetime of your application instances, dying may seem to be a good strategy, but what can happen is this can cause a cascade of failures, and which involves regenerating your instances and restarting them over and over and over again. And if the outage was transitory, that may not be so bad. But if the outage is persistent, then what you're going to have is the rest of your infrastructure is going to get hammered as your instance manager tries to regenerate instances in an environment where they won't start or run properly. Latency is 0. That's another famous one. In fact, all sorts of things cause latency. The biggest one is distance, but the number of hops and the amount of equipment between 2 points are all going to add latency. And so if we're thinking about setting up 2 data centers with DR, which is kind of the classic case, a rubric for a long time was 25 miles. A lot of people have said 50 miles or more to deal with natural disasters. And if you do a little research or whatever, you'll discover that for other kinds of things, like war conditions where there might be an electromagnetic pulse, or there might be adverse solar activity that is equivalent, that you want 300 plus miles, and it transpires that 321 miles is an easy thing to remember. And so for a lot of organizations, from a compliance point of view, that's the 300-ish mile radius between them is the thing. But when you're that far apart, the amount of latency just at light speed is a measurable number of milliseconds, rounding up 2 to 3. And then if you think about all the different pieces of infrastructure hardware that communication has to pass through, each of them adding fractions of a millisecond or even milliseconds of latency, the latency isn't 0. And so you have to deal with that. So that rears its head in terms of trying to keep distributed data in sync and so on. And there are techniques for dealing with that you should probably look at. And you should also understand when you do have an outage in one data center, and it's immediate, right? It's not it's an abrupt disconnection. What your potential loss is going to be like and what your recovery path is going to look like as well. Bandwidth is intimate. Man, I wish this were true. One of the selling points early on in the cloud revolution was this idea that since cloud providers are ginormous entities, right? Google, Microsoft, Amazon, and so on, that they effectively had so much high-tech hardware that you could get infinite bandwidth within a data center, or within what they would call a region or a point of presence or whatever. But the problem is the same problem that we talked about last time. Actually, two problems. One is you're going to want two regions, right, spread far apart. So you're going to be dealing with a latency issue. And the connection between those two regions isn't infinite. And the amount of bandwidth inside of a data center lives within the real constraints of budget and physics. And so that bandwidth is not infinite either, right? It's good in most cases, but it's not infinite. So if you have bandwidth sensitive applications and you can't re-architect them or refactor them to be more resilient, which would be your first best thing, then you need a way of measuring quality of services and have an SLA tied to that. And those things are going to cost money, but you're still not going to get infinite bandwidth, right? So it's important to consider when you're moving to a distributed environment that bandwidth is something that you have to care about in a way that you may not have had to care about it on your data center. The network is secure. So this is much better than it used to be. When Peter Deutsch wrote this paper, there were fewer tools in the toolbox to secure networks. Now there's a plethora of them. There are hardware solutions, there are software solutions, but even then we have to be aware that there are new vulnerabilities found all the time, new exploits found all the time, and nothing replaces carelessness. In the famous examples that you can go find on the internet where people have done various hardware surveys and find that networking equipment, for example, is set to the default settings and the password is either blank or password. Or they're not securing the devices using modern cryptographic techniques like certificates and key exchange and things like that. And so if you are on a public cloud, like Amazon or Azure or Google, and you follow the vendor's recommendations and you follow that up with procedures and processes of your own, you can have a pretty secure network, but there is no absolute security. There's only better or worse. And by the way, the fact that your InfoSec group is trying to beat back the bad occasionally causes application outages because there's an unintended consequence of trying to secure or strengthen the network. Topology doesn't change. I think today we would say that we just know this one isn't how the world is. If anything, businesses and agencies and organizations are moving faster than ever. They're deploying new features and functions, and those change the topology. They're deploying new ecosystems, and those change the topology. They're deploying new technologies, and those change the topology. And so, the only constant really is change. And so, that's an assumption I don't think anybody makes anymore, but it made the original top 8. So we stop and visit it. There's only one administrator. Back in the days when I first started doing computer science, when computers weren't even connected to each other and they filled a football field, that was probably true. or there were very few administrators. Today, the only place where there's really only one administrator is on my Raspberry Pi and on some VMs that are running on my laptop. Everywhere else, any serious network has thousands of people, right, in the loop. And if you're running on, a vendor's network, you have to understand that they have privileged access or may have privileged access to your network as well, and physical access and so on. And so by the time you start counting all the people and agents, like build agents and so on, that have administrative privilege at some level, right, unwinding the identity and access management puzzle when there's an incident can be really tricky. And so adopting modern practices about granting privilege, and in most cases, except perhaps in the rare non-production or sandbox scenario, the things doing the changes should be initiated from one process and executed by a different process that acquires its privilege only for the length of time it takes to do a task, and then loses that privilege again. And that's kind of a modern DevOps paradigm. But if anything, the number of system administrators or people with privileged roles has exploded over time. Transport cost is zero. I don't think anyone would consider that seriously anymore. And the truth is that you're going to pay one way or the other. And the reality is, when you're moving to a distributed computing environment where you're taking a data center and building another one so you have disaster recovery, or you're trying to distribute your user or customer load across multiple nodes or whatever, the one thing I guarantee is going to be true is that you'll probably underestimate the cost of that networking. And it's probably the single biggest thing in the classic 8 that's underestimated. The network is homogeneous. So I wish that were true. In fact, I've been to some really great data centers. I've had the very good luck to be allowed to go into my customers' data centers, and I've been a visiting fireman in some really great data centers with the rule that, no cameras, and I keep my hands in my pockets. And the one thing that you realize is that there isn't a corporation or agency on the planet that can afford to constantly be refreshing their network infrastructure. And there's no scenario in which typically, even if they could, that network is homogeneous, that the way that the network connects, the protocols, everything else is the same everywhere, unless the data center exists to do a single purpose, which is incredibly rare, is not going to happen. So we're going to have different vintages of networking. We're going to have different topologies because we're trying to serve different needs. And we're going to have a variety of protocols going over the wire. And all of those things destroy homogeneity. And the other thing that's important to understand is that if you're running on one of the public clouds, right, you are going to be on a shared network, right? They're going to give you a VLAN, which you can break up into pieces. You can have as many VLANs as you want typically. They're great security boundaries. They're great boundaries for controlling what component can talk to other components, but you're on shared infrastructure. Physical, wiring, so to speak, is going to be shared between you and other customers unless you contract for dedicated environments. And those are much more expensive, and they reduce a lot of the value proposition of migrating to a cloud. But so those are the basics that were proposed. Magenic has found 8 more for specifically cloud migrations. That's what my group does at Magenic. We help customers move to the cloud, whether that's making something that is greenfield, or whether we're making and migrating an existing data center, or we're trying to get some resiliency by spreading our workload between the data center and the cloud. Whatever the scenario, we've discovered 8 more fallacies. And for completeness, in respect to Mr. Deutsch, we've decided to letter ours to disambiguate one from the other. So let's talk about them. It will be cheaper than your data center. That could be true if you have scenarios in which you're doing general purpose computing, which is to say, websites, web services, headless things, databases, whatever, and you're moving to a public cloud, or you're moving to a shared tenant environment, or it just turns out that your loaded cost of owning your own data center doesn't really line up well with how your finance wants to run the company, and you're clever and you do all the right things in the right ways, then yes, it's usually cheaper than your data center. And in some cases, ironically, it's astoundingly cheaper, just because of quirks of how the data center you have was built, how it's operated, and your various costs that are not always obvious. So in order to get a handle on the cost component, Magenic has this process called portfolio rationalization. And what we do is we go through, and using inventory and discovery tools and cost management software of your choosing, we figure out who's who in the zoo, what talks to what kind of resources each business unit has, broken down into ecosystems, broken down into applications, broken down into deployable units. And then we use the tooling to do cost prediction based on the pricing provided by the vendor. And then typically the software has ways of putting in your contractual situation or your proposed costs and doing some what if modeling. And then typically these things are capable of monitoring things once they're moved to the cloud and seeing if you're actually recognizing the cost savings you forecasted. But the only way that it's cheaper than your data center is keeping an eye on it. And so before you do the migration, after you do the migration, you have to manage costs by keeping an eye on who and how your resources are being used, and what is it actually costing you day to day, and are there opportunities to have cost savings. And so a lot of these tools have machine learning or AI type tools built into them, and they can watch a system or set of systems run over a long period of time and make suggestions about what you could do that would lower the total cost of ownership without impacting the performance or stability of your system. Applications while similar performance. There's a rubric in enterprise architecture that changing the environment changes how systems work. And we always talk about this analogy of the weakest link in the chain, but in fact, distributed services aren't chains, they're big graphs. And there are a lot of very subtle differences from, say, taking something that's running on VMware vSphere, sitting on a solid 10 gig LAN with fiber channel connections to massive SANs, and how applications are written to run on those environments, and how they'll run when you start to break up those monoliths or even just move the monoliths to a different place. And by the way, that's true whether or not you're moving to a different data center or you're moving to the cloud or you're moving to containers. Your apps are going to run differently. And so you have to measure so that you get a baseline. And by the way, measuring, like saying, okay, we're going to measure on Tuesday and use those numbers for the rest of our project, is not a great thing. The only really rational way to understand the resource utilization of your systems and their performance and productivity is to measure over a pretty good sized window. And so if your system gets kind of steady traffic And there isn't any kind of seasonal component like an e-commerce site that might go crazy over the winter into the new year, then, you know, a month, 2 months, 3 months is pretty good. If you have periodic things, especially like month-end closings or year-end closings or some other periodic activity that causes a lot of computation to happen, or you're, you know, every quarter you recompute some baseline for something over a massive data set, right? You have to make sure that you're doing your measurements to account for those events. And the only way to know what those events are either to manage and monitor for a long time and see what's going on, or, well, and really, you should talk to the system owners and say, look, in terms of your business process, do you have periodic workloads that happen? And, you know, what do they do and how do they interact? And then, you know, you have to keep an eye on the things when you go to move them that are all going to affect your app performance. And the classic ones are sharing computing resources and changes in network latency. It may get better, it may get worse, right? And disk I/O. Disk I/O being a really important one if you're on the aforementioned kind of modern data center paradigm, because now we're going to be using storage platform as a service. We're going to be doing other kinds of I/O things, and it may be better, it may be worse, but it will change how your apps run. And in fact, I've seen apps fall over, not because their various dependencies, their resource dependencies are too slow, but because they're too fast. We take something that's been running happily on some old hardware and we put it on some new hardware, and I've actually seen systems fall over because essentially they overclock themselves to death. So, you know, you have to measure and get a baseline and understand that there will be changes in performance. And I've never seen a migration that didn't have an element of modernization for this and a million other reasons. The code is suitable for the cloud. So sort of continuing this theme, right, that the code that your teams wrote and has been running steadily for you, hopefully steadily, will run happily in the cloud really depends on a couple things. It depends on its vintage. It depends on whether or not you're just lifting and shifting virtual machines to a new place. But in many cases, when you do that, you're going to need to upgrade your operating system or your platform runtime or whatever, and you're going to have some issues. It may be that your app is a monolith, or your app pretends like it's got an enormous SAN underneath it and it's going to run the same way, and it won't. And so if you have, for example, large-scale data processing problems, recomputing large data sets, and you've written code to do that, it makes certain assumptions about your topology. Those things may need to get rewritten. It's not that you can't do them. It's just that in the cloud, you need a different, more modern strategy for moving those to a more distributed type of workload that also has the advantage that the resources can be bursty. In other words, you can allocate resources and on demand, pay for what you use, and then get rid of them when you're not using them. But you have to sort of challenge this assumption that it goes, oh, this app system will just move to the cloud. It'll be fine. Because it may be fine, but it may not. And so some analysis is worth doing. And we're really fond of a process called Snap. And Snap gets right to the heart of talking with the application teams, and in a very short period of time, like hours, figuring out or detecting kind of 80% of the things that are likely to cause the team's grief when you go to move it. And then that, coupled with the baselining and monitoring we talked about before, gives us the data we need to make credible projections about what we're going to have to do to get the code to go to the cloud. The cloud is more secure. Actually, honestly, I think that is in many cases true, assuming that you have followed the vendor's best practice guidance. one of the things that I always am stunned by is occasionally someone will say, well, our InfoSec team has secured our network way better than Microsoft or Google or Amazon could. And I said, well, how many people are on the team? And they go, 3. And I go, Microsoft has 3 people in one cubicle. They have literally 1,000+ people, many of whom with serious experience and PhDs. And all they think about all day is making their networks and their application systems and things more robust. And they have access because they can buy in bulk, and there's savings at scale. They can invest in the sorts of technologies that might be out of the reach of your IT budget. So the cloud could be more secure, but you have to very carefully understand the differences in network topography and management practices when you move out of your data center and into the cloud. And you're going to need to make some changes to how you do things. And so your compliance organization, your InfoSec organization, your IT organization is going to have to show some ductility in understanding that you can't really do things the way you did them before, that there are equivalent and generally better ways of doing things, and they need to be focused on the goal, not the process, right? Process changes, but goals stay the same. We don't want people getting access to this data or computation that shouldn't have it. So that never changes. So being goal-focused helps drive you to having as a secure or more secure environments in the cloud than you do on the premise, potentially, right? But there's some work you need to do. Clouds are easier to manage. I don't know about easier. They are different to manage. The first thing is that typically the vendors, whether it's one of the big public cloud providers or hosting or whatever, they already have a bunch of management tools that are sort of baked into the fabric of what they do. And they're the same tools they use to manage their overall hosting environment. So how you manage things, what metrics that you can get, what events you can observe, what logs you can aggregate. The mechanics are generally easier in the cloud because the cloud vendor has done a ton of work for you. But again, ductility is required because you're going to have to change how you do things. You may even have to change how you think about managing networks. And you're going to want to get the best value out of the cloud, you're going to need to adopt a modern DevOps program, which means that robots are going to be doing most of the work, and you're going to be using tools like Chef, Puppet, Terraform, Ansible, and so on to do your deployments and provisionings, and even to make provisioning and deployment adjustments or tweaks. And that can be a pretty steep learning curve. The advantage, though, is that process will effectively help your organization climb the hill of CMMI, which will make your IT program more effective. And by effective, what I mean is the amount of money you spend for the value you get goes up, right? So we invest on the front end a little bit, and we get value in the back end. And that's what we're trying to help customers get to. Any application can be containerized. I actually saw someone at a conference say this out loud, and I thought, oh, they're making a joke. They're going to, pull back on that statement. And what they did was they doubled down on it. Well, that hasn't been our experience, because money is not infinite. And so when we're thinking about containerizing an application, the first question we have to ask is, what is the cost versus what is the benefit or value of that operation, right? Not everything you can, if you tried hard enough, I bet you could make almost anything that isn't too stateful run in a container. But the truth is that because containers are different than virtual machines, right? Virtual machines try to emulate the behavior of real hardware. In other words, their lifetimes are supposed to be very, very long, right? The mean time between failures should be measured in days. I've seen hardware running in data centers that's been running uninterrupted for years and years, especially modular hardware systems. But containers are a different beast than a virtual machine. It's not just the next generation of virtual machine in the same way that functions are not the next generation of containers, right? They're a way of doing computation that is suited for some use cases, but completely unsuited for others. So, here's some things to be aware of. Statefulness, singletons, affinity, disposability, and I put in a link to 12factor.net, which I think everyone who's thinking about the cloud should go read. It's very short, but a very nice punch list of things that you should really care about or think about when you're moving to any kind of cloud. In fact, if you're making any kind of enterprise architecture change at all. And the problem with writing software based on the assumption that the computing environment you have has an enormously long mean time between failure, and that they're designed inherently to come up and stay up, is not really how containers, or for that matter, functions work. They're designed to come and go based on demand, which means that traditional client-server software that wants to start up, pull up a bunch of state, do a lot of stateful interactions within itself, are not going to shut down quick enough to be good container fodder, right? You're going to have loss of data, loss of processing. You're going to have some other things that are not great that will cause loss of business value, and you don't want that. So if you're going to move to containers, just know that it's going to force you towards adopting some more enterprise or distributed architecture type patterns, some cloud patterns, like unit of work and restartability, and considering Saga, and that, sort of headless process a record at a time as they show up sort of things work really well, as do websites and web services typically. And other kinds of traditional data processing where it's the end of the month and now we're going to churn through 100 million records and generate invoices, right, are maybe better suited to virtual machines or rewritten to leverage distributed data computing in cloud environments. Basic dependencies exist and act the same. So I won't say which cloud provider it was, but we arrived after the customer had pre-selected the vendor and done a long-term deal with them, right? So the die was cast, they had a minimum spend, we just had to go with it. And our team was like, okay, that'll be interesting. We'll have to learn some things. And there'll probably be some things about this cloud that's different than this other cloud. And the first thing we ran into was that the cloud didn't have a credible solution for dealing with shared volumes. In other words, NFS and CIFS file systems. So no one had thought about it, because if you work in the data center environments, it's table stakes these days that you have a SAN or other massive storage thing, and that massive storage thing knows how to talk to Linux and Unix and Windows and everything, and that it supports a bunch of different protocols, and that it's distributed, reliable, and robust, that it can be replicated across data centers. It's got backups and snapshots and all the things that you'd expect out of a modern storage infrastructure, but it wasn't there. So we had to punt, right? We had to rewrite a bunch of code. We had to make some adjustments. We had to move to bucket storage, which is a great storage paradigm. It had many desirable features, but it was code we had to change. And the other thing that isn't obvious is that a lot of your operations in terms of disk I/O are going to be across the wire. And so that's different than having, you know, a fiber channel card and having a big fat light pipe to your SAN. And that's just one example of how some of the basics of client-server computing that we sort of count on don't necessarily live happily. If you're not on Azure, for example, you may discover, if you have a dependency on Microsoft Windows, that Windows is very much a second-class citizen in that cloud, and that may not make you very happy. Migration is easy, fast, and cheap. Well, okay. Everybody knows there's no such thing as easy, fast, or cheap. Generally speaking, the running joke for the iron triangle is you pick two. What we're saying is, for the first year, you should probably settle for one. So the fast would be lift and shifting your virtual machines into the cloud, right? Using some tooling and some techniques and some advice from your vendor and some automation, right? We just pick up your data center and we move it into the cloud, and we kind of deal with the pieces as pieces fall off. And that's generally pretty fast. But year after year, that's more expensive than if you had done native hosting in the cloud or containers or whatever, right? There's a trade-off to be had there. And so what we say is you've got to do a balancing act. And it's the right level of granularity for doing that balancing act is at the ecosystem level or below. And that is to say, we don't say, well, this entire business unit is going to be lift and shift, and this entire business unit, we're going to transform their apps into containers. And, you know, what you have to do is you have to look at the fact that these business units are going to own software systems of different vintages, different architectures, technologies, topologies, and you're going to have to get down to the ecosystem level, go below that to the application level, and maybe even to the deployable unit level, and say, this is how we're going to deal with SQL Server. This is how we're going to deal with Postgres. This is how we're going to deal with applications that do this. This is how we're going to deal with applications that do that. And if you break that down, what you end up getting is a couple of big categories for how you're going to handle things, but you need to do it at a low enough level of granularity that you seize every opportunity to get either fast or cheap. And if you do it in too big a granularity, it will neither be fast nor cheap. Certainly, none of this is easy, but that's why I exist in the universe, according to my boss. And so, you know, you have to really think about that. I've seen a lot of vendor advertising that seems to imply that you can point their magnificently expensive software and hardware at your data center and they will just transplant it into Amazon or whatever. And while those tools are super helpful, the promise that it'll be easy, fast, and cheap isn't true. So there you go. I hope this was a useful guide to the original 8 fallacies of distributed computing and the modern 8 fallacies of cloud computing, and it gave you something to think about. Feel free to reach out if you have questions or you're interested in talking about it more.